everyone. Welcome back to SAT Math Question of the Day with Professor Emeritus Seth Chaiken at University of Albany and Joel, Seth's brother. We're here to hopefully help you approach how to study for the Math SAT and also how to approach doing actual SAT math questions. Approaching the studying for the SAT is pretty clear. You will sign up for the SAT and then you go to the Khan Academy official practice. We're only assuming the digital SAT now. Because that's going to start in the winter of 2024. And if you want to see how to get the free Khan practice for all the questions and all the topics on the test, go to and watch our video from June 29th. It'll show you exactly where to find all this practice. So we're just going through these practice questions one by one. We're only doing the advanced. And today we're going to do graphs of linear systems and inequalities. Here we go. We're going to be doing the first, we're going to be doing one advanced. We do one advanced question a day with the idea that if we understand it, we go through how to approach an advanced question, you could then do the moderate and easier questions yourself. Let's go. Okay, here we have a graph of linear system of inequalities. Did I say that right, Seth? A system of inequalities. Okay, here we go. So please read it, pause it, and then we will do it together. If 8, B is a solution to the system of inequalities, what is the minimum value of B? Wow, okay. Do we just throw 8 into x and just sort of see what happens and solve for both y's and see which y is less? I haven't seen a problem like this in a long time.
Well, you need a solution. No, it's even simpler.
Okay.
You throw, as you said, substitute or throw the 8 into the x.
So let me do that.
And hold on. And the b into the y.
Right.
And then you solve for b.
Right.
And what you're going to get is an inequality, some inequalities in b. You find what the solution set is. And then pick the minimum, if there is, value of b that satisfies the system.
I hate to say that, Seth, but let's go back to the videotape. Isn't that exactly what I just said?
You said you said something too complicated about y.
I just said throw 8 in there. And then you get equations for y, but y is b, and then you see.
Yeah.
Okay. 18 times 8. We're allowed to use a calculator on the digital SAT.
Yeah.
Oh, plus 6. Okay. Notice I'm doing it a little slowly because you can easily make a mistake here.
Like you just did. Check your multiplication.
Yeah.
The 20 times 8, what is that number?
160.
Okay. 160.
160. So 3b is greater than or equal to 150. So b has to be greater than or equal to 50. Oh, that's cool. I can understand that. B is to be greater than or equal to 50. Fine. Now, what about this one? B has to be greater than or equal to minus 160. Is this a coincidence or something? Are they playing with us? Because the two equations say the same thing.
Oh, they do?
Wait.
Yeah.
There's something strange. That's just a little weird. They didn't have to, did they?
For the two B's? Not necessarily.
The same thing.
Let's see. 3B is greater than... But 8 times 18 is 144.
Right. Yeah, plus 6 is 150.
6,
so 3b is greater than that, right? And then 8 times 20, just to be short, is 150. So B is obviously, then B is 50.
So what do you do there? So 3B, got 3B is greater than 150. What's that, 160?
Right. Now, this is so funny
Right,
because
50. Yeah. So there's both the equations, the two inequalities are equivalent. So
right,
the B's that satisfy the B's that satisfy it are B's that are greater than or if equal to 50.
right. Now, the thing that's strange about this is this is under the topic. Now, you won't know this on the actual SAT, but here it says graphs of. We didn't use any graphs. We didn't do any
Well,
graphs.
yeah, no, you're not using. You don't need to use a graph,
Well, I'll
but
tell you what.
there'll be other questions that are about the graph.
No, but
You could draw a graph of this thing if you want.
Yeah. So why don't we first check the answer? And before we see how they do it, why don't we graph it? Now, when you graph, you can sign up for this blue book thing with the SAT people, and you can practice, and you get a Desmos calculator on the computer. For some reason, they don't give us a Desmos calculator here, which is not great, because they really should give us a Desmos calculator. But why don't we do it on Desmos? And then let's see what happens, because this is what people will actually do and see. So before we do that, we have to write down the equations. So let's try that. Have you ever played with Desmos, Seth?
I forgot if I looked. You told me about it. I forgot if I looked at it.
3y is greater than 18x plus 6. 20x plus y is greater than or equal to 210. Okay, first of all, why don't we see if we're right? Or if our answer agrees with theirs. So why don't we say 50, right? Okay, that's fine. So let us.
It likes it.
Yeah, let's go to Desmos. Desmos graphing calculator, the best thing in the world. Okay, Desmos graphing calculator. Now let's do an experiment. Can we just not even solve for y?
Right,
and
don't
just
solve for
throw
y.
this in.
Yeah.
Okay, that's cool. Now notice this is how you probably would want to actually do it. First, you certainly are going to want to be very familiar with Desmos going into the digital SAT.
Yeah. Right.
Okay. All right. I think Oh my God! It's the same graph.
Oh.
Look, see if I change it to 311. No, if I change it to 310.
No.
If I change it to 500, change it to 0, we get something else, right? We get a different thing. But if we change it to 10, now this could be deceptive. The thing could be somewhere else. There it is. See? So
Yeah. There it is. Okay. Yeah, that looks better.
So you gotta be careful to zoom out just because you see it.
Yeah.
Now I'm gonna double check to make sure that I copied everything right. Now, do you remember what the x was? The x was 8?
Yeah, it was 8.
Oh, look at that! Wow. So
could you mark? Oh, there you go.
There you go. Look at that. So when x is 8, the lowest value is 50. Right. That's weird. But they could have said when x is 0. Oh, wait, could they? Could they have? Let's say they said x is 1. Let's say they said x is 2. When x is 2, that would be the answer,
when x is 2. When x is 2.
No. When x is 3.2.
Let's say when x is 2. When x is 2.
When
x is 2. Okay, here we have points where x is 2, and the red inequality is satisfied, but the blue one isn't. But I'm going up and up and up, and see this line. The slope of the blue line is negative.
Right.
What you don't see because it's not in the view is that if I keep going up, I'm eventually going to hit the blue line.
Right.
And so while I'm still in the red region, I will enter the blue region. And so the point is, a solution to the system is any point that is both red and blue.
Okay.
And so solutions to the system are the points that are in this wedge.
Right.
Right?
So
Okay.
here I have there it is. See, it's very close to
Yeah.
2. There we go.
So
there.
in fact,
214. So the red
Yeah.
line says 214, and the
Yeah.
blue line would say 2 big number. Big number, like 2, like 300 or
Yeah.
something.
You're picking the points. Yeah.
Yeah, there it is. Yeah, 214.
Yeah.
There we go. See, there it is. 214.
Yeah.
So I can mark.
So in this question, in this question, let's use x and y. Y equals 50 is the minimum value of y for which there is a solution. Okay? And what they did was they gave you the x
Yeah.
for which the minimum solution for y is 50. Okay, so they gave you the x for the solution that minimizes y. Okay, so they must have made that up as to be a coincidence.
But okay, let's say x was 2. If x was 2, then the answer would be 14.
No. If x is 2, the answer for y would be some big value of y that's out of our view. It's up there.
No, they were saying,
where this blue line will intersect this vertical.
No, but they were saying for the smallest value of b.
I know that this 214 does not satisfy the blue inequality.
Oh, right, because it's not.
Oh, right. Yes, it's not in the blue region.
It's not in the blue region, right. Right.
I said that the solution to the system, a solution to the system is any point that is both
yes
in the red region and the blue region are the only points that are both are the ones you see here and are go way up, all the way up here,
Right.
The way where is it? Up here.
Right. Yeah.
Yeah, this stuff.
So is there a possible x that can have no answer?
Well, is that possible? Is that possible? I would say no.
Really?
Because this cone, even though it looks really, really narrow,
right,
the two sides go up and then to the right in opposite directions.
Right.
So no matter how big or small the x is, you'll eventually get to some height that is so high that the that x value is a point that's within the cone. So for every x, there's a y for which xy is the solution.
Right. The way
now, what you don't have, it's not true that for every y, there's a solution with that y.
Right.
For example, y equals 32 gives you the lines that are this way, and none of them are in the cone that's up there.
Right.
Huh?
Yeah. So let's make it really clear. Let's make the cone green. Right.
Yeah.
And that sort of looks like an absolute value function. It looks like, you could think of it as a thing that looks like this. You know that the absolute value function, the all x, the domain for this thing is all x. So in other words, in all x, you could
Yeah.
find a y that satisfies the equation. That's what Seth said. No matter
Well,
because that
well, the
v,
let's be a bit more accurate. The absolute value function, the lines have 45
yeah, I know
degree
both stuff. No, no,
angles.
no. But conceptually, it's this very similar to an absolute value function in that no matter what x you have, there will be a y. And
Yeah.
here, this has a very similar shape. It's just a v. It's just a v.
Well,
Just
it's
starting.
similar in that the two lines partition the plane into four parts.
Yeah.
One, two, three, four, and the solution set is one of the four parts.
Mm.
And it includes the points that are on the line as well as the point here. That's because the inequality relations are less than or equal. They include equality.
Mm. So I have one. Let's just make it a little harder, so that we really, it's like a cavity. You want to drill down. Really, let's open everything
Yeah.
up to really explain what's
Yeah.
going on here.
Yeah.
So here, it just happened to work out. It was very nice that both equations gave the same answer. But now we already know the answer here, which I made a mistake. I said it was 214, but Seth's right. It's really way up on top. It's like some big number. Let's try
Well,
to
you could figure it out.
do this. Let's try to do this problem algebraically.
Well, how do you figure? Yeah, we want to do this. Okay, do this problem
So if we do
algebraically.
this problem algebraically, well,
So you plug
if you
in.
put the 2 in there, you get 3y is greater than
Or
2
equal.
times 18 is 36. Do you want me to put a b in there or not a y? You want me to put
No,
a b?
no.
B, leave it as a y?
You leave as a y, yeah.
Okay. Now, 20x, I think I can do that. 40 plus y is greater than 210. So 3y is greater than or equal to 42. So that's this one, the red one. And
Yeah.
y has to be greater than or equal to 170.
Okay.
Y has to be greater than 170.
Okay. Well, divide by the 3. So y has to be greater than or to be a solution.
Right.
Y has to be greater than or equal to 3 into 14 is 14. And y has to also be greater than or equal to 170.
Right. So,
and the only way you can have both is for y to be greater than or equal to 170.
Right.
So the smaller the solution for which x equals 2, the solution that has the greatest y is the solution x equals 2 and y equals 170.
No, the smallest y.
Yes, the solution with the smallest y. Oh, sorry. Oh, mistake. The solution with the small for which x is 2 and y is the smallest possible value is 170.
Right. So the largest for the largest possible value, there are an infinite number of those.
There's no largest y.
There's no largest y. Right.
Yeah.
So the operative word here is the word and. So
yes,
if you just
and.
See this, so do you notice the mistake I made? I think it's so valuable. I make a lot of mistakes. To learn from your mistake, to say, well, what did I do wrong? I said 14. No, that was wrong. What I was doing here is I let my eye deceive me with my head. My eye and my head deceived me. When I solved this equation, when I essentially saw this, I said, oh, 14 is the answer. Oh, look at that. 14 is the answer. And that's what I said. I only saw this equation. I did not see this equation. Seth said, no, you got to, this lower equation, the y greater than 170, is the blue line, which frankly I didn't really notice, and that's why I made the mistake.
Well, you plotted them. You plotted both of them.
Yeah.
One of them, the solution set came out red, and the other one in the solution set came out blue.
You know, usually I'm a big fan of the graphing modality. You get a lot of insight from the graphing modality, but this one, frankly, if I did it this way, I think I would have made a mistake because I would have done each one and I would have said, oh, it has to satisfy both. The operative word is and. You need a number that's greater than 14 and greater than 170 at the same time. Yeah. So the only number that can be both greater than 14 and greater than 170 at the same time is only 170.
Now, any systems of equations, systems of inequalities, or you could even have both. You could have a system composed of one equation and one inequality.
Right.
When we talk about the solution to the system, or a solution to the system, we're talking about numbers that satisfy every equation or inequality in the system. And every means the first one and the second one.
Yeah.
And if there are many of them, or third, so and the third one and the fourth one.
Right. So it's pretty constricted. That's like life, right? In life, that's what makes life so complicated, is that the solution to life has to satisfy all the constraints that we live under.
Well, not always. Not always. You could be happy, pizza or ice cream.
Well, that's an or.
I'll be happy if I have a slice of pizza or a cone of ice cream.
Yeah, but that's an or. We're talking and.
I know, but it's not. That's life, but it's not the same as a system of equations or inequalities.
Right.
Conceivably, mathematically, it makes sense to talk about, like the solution set that satisfies one equation or another equation.
Right. Yeah. Which we're not going to do that.
Yeah, but everyone who poses such a question has to be very careful and specify just what they want.
Exactly. Those are more complicated inequalities. I guess we'll see if we get any of those. We're going to be doing
those are messier.
Yeah.
Yeah.
Yeah, because you can get really weird answers. Maybe we'll get a few because we plan to do all of the advanced questions on this. We're going to be here for a while. We're going to be here for a few years, God willing. Okay, so great. So you do two modalities. Frankly, I would feel more comfortable with the algebraic modality with this one for this problem. But anyway, Desmos is your friend. So let us now get rid of Desmos.
Well, this problem, the numbers are very large. They're too large to conveniently sketch.
Yes.
Sketch the situation graphically.
Right. So then, when you're on the computer, make sure you use the screen thing. Oops. Make sure you blow things up like this, or you make things smaller. Really important with Desmos. Be ready for that. There's a mistake I'm sure most people will make when studying.
So were you just using Desmos?
Yeah, absolutely. Which is the graphing calculator that everyone's going to get on the SAT. Okay, so here we are. Ready? So let's see.
Desmos did not automatically zoom in or blow up.
No.
To show.
Yeah, you have to use your fingers. You have to use your fingers.
Yeah.
Now, what happens if it's not a touchscring computer? Then what do? Then you use the control plus sign, control minus sign. These are the things you got to practice. Talking to the audience, these are the things you got to practice before you take this digital SAT. How you're going to blow things up and expand things with Desmos. I don't know the answer. I guess it depends on your computer.
Yeah.
Makes things more complicated now. Okay, let's see how they do it. This time they gave us the whole thing. Notice there's no graph. Isn't that strange? Very strange that the topic was graphs of, but they didn't use a graph.
Yeah.
Anyway, look, they did it the same way we did. To substitute x into 8 and solve for y, the minimum value y satisfies both inequalities. Notice the word both. That is such an operative word. Unfortunately, it meant, particularly for me, because when I said 14, I wasn't saying both. Some sensitive to that mistake. For x is 8, you get this. X is greater than 50. This, you get x is y is greater. No, y is greater than 50. Sorry, y is greater than 50. Y is greater than 50 again. The minimum value might satisfies is also 50, so 50 is minimum value. So,
what a coincidence.
Yeah, so it would have been a lot harder if they weren't the same, because you would have had to think a little more.
Yeah. If you get a different value in each one, and then you have to decide which one. Y is greater than this and greater than that. You need to the minimum value is the one that's greater.
Yes,
because the y has to be greater than both of the numbers.
Yeah.
So you have to pick the y that is both greater than or equal to one number and greater than or equal to the other number. So it has to be greater than or equal to the smallest number. So the smallest y that satisfies the two inequalities is the greatest number, right, of these two sides.
Yeah. Sometimes, particularly like when you do composition of functions, I always say, stop thinking, just do exactly what you're told. But in this problem, in these problems, it seems like on the digital SAT, they're really asking you to think more. There seems to be a trend on these digital questions is to really, you really have to think. So anyway, we will continue our analysis in due time and give you our thoughts, whatever they are worth. Hopefully they are worth something. Whatever they are worth. Hopefully you're getting something out of this.
Okay, how much time of our audience did we waste today?
20 so far. 27 minutes and 10 seconds.
Say we wasted 27 minutes and 30 seconds of your time. Thank you.
Okay, no, seriously, hopefully you're getting something out of it. But also take a look at how we approach the stuff. Notice we just don't do the problem. We say, well, what is really going on here? Like, or if you make a mistake, like I tend to do a lot, like, why did I make that mistake? What didn't I understand? That's the approach that you should take in all problem solving, is really understanding when you make the mistake. The mistake in some ways is a gift, because it opens up the opportunity to really grow and learn and get better. So, except it's frustrating when you keep making mistakes all the time. But no, eventually the insight helps you with future problems. Anyway, enough said. So please like us, dislike us, give us comments on our YouTube videos, or email us at satmathquestionoftheday@gmail.com. And we hope to see you next time we meet, which hopefully will be tomorrow. Take care, everyone. Bye.
Bye-bye.